What's up everyone, welcome back to Just Finished Coding. This is part 4 of our Tic Tac Toe AI series on Scratch 3. So let's get coding.
Just finished coding.
Now quick interjection here, if you've not watched parts 1 to 3, please watch them before you come here because we're picking up from where we left off and you'll be very lost. I'll leave a card for you right here. Please watch the video and then come right back. Now if you're still here, I'm going to assume that you've watched parts 1 to 3, in which case your program should resemble mine, and when I click the green flag and then on one of the squares, you should have a pretty neat X drawn up. And if you don't, then I do recommend you check out the previous videos and fix your bugs before you come here. Now if you've got the X working fine, let's actually move on, and in this video we'll be mainly dealing with our computer AI, and we'll actually have an exciting move made by the computer AI. Now before I get into that though, I do want to fix one small thing, and that is our backdrop. So click on stage, go to backdrops, and then you could choose paint in any backdrop that you want. I'm just going to make a nice black background, and you could follow me if you want. Just draw a black rectangle and make it fill throughout the screen, and keep in mind that this is just a backdrop, so you could use any backdrop that you want if you think that'll look cooler. So that's up to you. Alright, with that out of the way, let's now get into our AI. So within choose a sprite, what you want to do is to click on paint a new sprite and then head over to the code. And you do not want to paint anything in the costumes, just like you did for the initializer. Now keep in mind, in the initializer in the last video, we didn't actually initialize any lists, and we will have to do that in this video, but I am going to code a bit of our AI first. I'm going to call the sprite comp. You could call it AI or anything else you want, that really doesn't matter. Now within our computer, you're not going to have a usual when green flag clicked yet. What you want to do instead is to have this block of code which says when I receive comp to play. In this case, this is the time that the computer actually has to make its move. So I'm going to create a variable right now called played, and this is actually going to regulate the computer's move. Now if you don't understand this completely, it's fine. This will make sense in due time. So initially we want to set played to be equals to false, and basically the idea of played is to make sure that each step of the computer's algorithm doesn't proceed if the previous step has already been made. So if the computer has used, let's say, step 1 of its 5-step algorithm, and that particular step has yielded it a move, then it's not going to move ahead to step 2, and it's instead going to make its move immediately. That's what this variable is going to do. Now how we'll do that is a different issue, and I will come to that a little bit later. So once you've set played to false, what you want to do now is to make up a new function, and you can do that by going to my blocks and clicking on make a block. Now if you don't know what functions are or blocks in Scratch, they're basically a container where you can put in a predefined block of code, and then you can call that function anytime you want instead of typing in or putting the blocks of code every single time. It's basically like a substitution where you've made up a variable, but instead of a variable just holding one value, a function would hold, or a block in this case, would hold multiple lines of code instead. That's pretty much it. So for this function, we're going to be calling it check center, and you don't want to click on any of these things. You just want to click OK. There we are. And if you did that correctly, you should have something like this, like define check center. So perfect. Now I haven't told you guys what our algorithm is actually going to do, and I'm going to do that right now. So our algorithm is going to go in a few steps. Now the first thing it would do is to check if the computer can actually win in that particular move itself, and if it can, it's going to make that winning move. Now if the computer cannot win, then it's going to check if the player can win, and if the player can win in the next move, it's going to block that particular square. Now if the player cannot win in the next move either, then the computer is going to check if the center square is vacant. If the center square is vacant, then that's going to be the computer's move, and if the center square is not vacant, it's going to check if the corners are vacant. Now if the corners are not vacant, it's going to make a move on one of the edges. And that's the overall idea of how our computer AI is going to work. Now keep in mind, in the next few tutorials we will be adding a few more enhancements to this AI with danger positions and so on. I won't get too much into them in this video, but keep in mind that there's a little more than just that. Now in this video, what I will be doing is to code in 3 functions. the check center, the check corner, and the check edge, and the winning sequences will be done in the next video. So within define check center, what you want to do is the following. So you want to grab an if from the control section and put in a simple equals to from operators. Now keep in mind that the center is square number 5. So our square number would be 5 in case of the center. And what we want to do on the left side of the equals to is to head over to variables and grab this. Actually, never mind. You can throw out that equals to, and you could just directly put in if possible moves contains 5. This would be simpler. You could use that method, but I would prefer you use this. So if possible moves contains 5, it means that center has not been occupied yet, in which case let's make that as our move. So what we would do right now is to set move to be equals to 5. And in case you do not remember, in part 1 or part 2, I don't remember which one, we had this code right here which says when I receive move made, if move is equals to square number, and this move is going to correspond to our computer move. So there we are. So set move to be equals to 5, and then we are going to do one more thing, and that is to set played to be equals to true. And like I mentioned, played regulates our computer move. So if the computer has made its move, played would become true and it would not move on to the next step of our algorithm. So that would be check center. Now for check corner, you could just, oopsie, not add a comment. You could just duplicate this and yeah, this one particularly, not the entire comment, not the entire block. So now you can click on make a block and call this check corner. There we are, and hit OK. You do not need any parameters. Now within check corner, you'd like to put the exact same thing, but you'd also want to change it a little bit. So within check corner, add an if else instead of an if, and you put that condition there and change the 5 to 1. You put in the exact same blocks of code, but you change the move to be this corresponding value. Now the corner squares are 1, 3, 7, and 9. So we'd want 3 if else's, and the fourth one would be an if. So I'm going to duplicate this for the fourth one and put it right inside that. There we are. Now let's change each one. So if possible moves contains 3, that's another corner. Now possible moves contains 7, that's another corner. If possible moves contains 9, then that's another corner. And there we are. So this would be our check corner. Now next we'll go into our check edge. So click on within my blocks, make a block once again, and say check edge. There we are. Hit OK, and you want to duplicate the exact same blocks of code which you put in for corner, and just change the 1, 3, 7, 9 to 2, 4, 6, and 8. 6, 8, and you also want to change the move mates to be their respective values. So this is going to be 2. Oopsie, what did I do? Control Z that, yeah. So 2, this is going to be 4, this is going to be 6, and this is going to be 8. Perfect. And that is all we'll have for our 3 blocks of code. Now keep in mind that just because you've defined a block, that doesn't mean that code would initialize or start at any point in time. And to do that, we'll actually have to call the function, and you can do that by just going to my blocks and putting in the code right there. I'm not going to do that for now. I'll do that after I do the initializations. So now head over to your initializer sprite and click on variables. Now I am going to be initializing these 2 lists, that is possible moves and the square list. Now to initialize our square list, our process is pretty simple. We're just going to have a repeat 9, and now within variables and list, what we're going to do is to add thing to a square list, and I'm just going to hit the space bar right there. So this contains a space, and since our square list is always going to have a fixed number of elements, we will not actually be deleting stuffs, and each element would correspond to the particular square number. We wouldn't really be having any item inside it if the square is vacant. So if the square is vacant, what we're just having is a space. Now keep in mind that within our inside variable right here, we actually had a v, and you could use ov if you want, but I'm just going to leave a space because I think that's a little bit easier to understand. So we'll just have this block of code right here. Now we want to initialize a variable called c. This is just going to make our, the possible moves easier to initialize. and I'll explain why in a minute. But you want to click on for the sprite only so that you avoid cluttering the computer AI sprite with variables that it isn't really going to use. Now I'm going to hide all these variables before I proceed. There we are. So initially I want to set C to be 1, and now I want to repeat 9, but I want to do something slightly different. So instead of adding stuff to square list, I'm going to be adding it to possible moves, and instead of a space bar, I'm going to add the variable C. If you just leave it right here, you just have 9 ones in the possible moves list, and we actually want 1, 2, 3, 4, so on until 9. So what you can do is just change C by 1, and this is going to ensure that the variable keeps changing and your possible moves is going to have the values 1 to 9. And that is why we use a variable instead of just saying add 1 to possible moves, add 2 to possible moves, add 3 to possible moves, and so on. Before you actually move on to your AI sprite, there are two more lines of code that you need to put in, and that is to delete all of the possible moves list and the square list initially. Because whenever we hit the green flag, we want the program to restart, and if we do not have this, it's going to remember whatever we had in that list from last time, and that's going to be something that we do not want to happen. So with that out of the way, let's now move into our computer AI. So within our comp to play, I would suggest moving this to a top corner or something, because this is going to be pretty long. And let's get into the code. So I'm going to have if played is equals to false every single time we actually use one of our functions. So if head over to variables, grab the played is equals to false, then we will be using this block of code which says check center. Now you can just duplicate this if played is equals to false. Now put in our check corner, and now you can duplicate this once more and put in the check edge. So there we are. Now keep in mind we've had that particular move, and in order to change the costume of the sprite, what we'd want to do is to actually broadcast this message which says move made. Now we haven't actually deleted any items of our list yet, so we'd have to remove that particular item from possible moves right away. So what you'd want to do right before you broadcast that message is to head over to your lists within variables and grab this block of code which says delete one of possible moves, and you want to change that to delete move of square list. Actually, no, just a second. You don't want to delete the move, you want to replace move. So you want to grab this block of code which says replace item 1 of possible moves with thing, and you want to say replace item 1 of square list with an O, not a 0 but an O, and then you want to delete item not 1 of possible moves, but you want to delete item number of move in possible moves of possible moves, and there we are. And now we just broadcast our message, move is made. There we are. Perfect. Now if you didn't understand this completely, I'll explain that to you right now. So we'd want our square list to constantly update with the corresponding square values containing what is inside that particular square, and that is what this first line of code which says replace item move of square list with O basically does. It's going to update the square list with an O wherever on whichever square we made the move. Now the second line of code is going to ensure that we delete that square number where we've made a move from the possible moves list. Now if we just put delete move of possible moves, it's actually going to delete the list item of move of the possible moves list. So since we're deleting values from that list, that's not going to be what we want to do. Because let's just say we had 6 items in our list where we had 1, 3, 5, 7 and 8, just as an example. Okay, 7, 8 and I think that was 5, so let's just say we had 9 along with that. Now keep in mind that 5 would not be the 5th element of the list, since we are constantly deleting stuff from the list, and what we'd have to do is to instead find the item number of that particular move and then delete that. So that is what this line of code does, and once we've done these two things, we can just broadcast our move, and that is pretty much it. So now when we hit the green flag, and now we can just make our move, you can see the computer also makes its particular move, and although it isn't the smartest AI and I can actually defeat it, it still makes a move, but we can actually defeat it and the computer does play. It still makes moves, and that is pretty exciting. And that's it we'll be coding in this video. If you've enjoyed this video, please make sure you leave a like and also do not forget to subscribe and turn on the notification bell. Thank you so much for watching everyone, and I'll see you in the next video.